correlation analysis and regression analysis. So one of the chapters in our present research methods, right? So which I have to, deal with, or I have to handle. Right? So due to some busy schedule, I could not, before this I could not, conduct what's called online class. But others, I hope that used to take online classes before the start of this offline class. Now, of course, we have both online and offline classes, right? I think most of you joined via because I have Google Classroom. So already sent the link to us. What you already joined. For others have not joined, kindly join, because it is not possible to for all the aspects of class, whatever the material or related things you have to, and then you take. Because situation we cannot, after some time again, situation may change. Right? And therefore, especially this year 2020, now is not yet over. Correct? It is not usual, some extraordinary situation. Right? So, correlation and regression analysis. So we will discuss first correlation analysis. In fact, we can establish correlation only on the basis of regression analysis. Strictly speaking, only because regression analysis is used for the purpose of what's called estimating or predicting the future value based upon the given value of one or more than one variable, upon which this variable whose value has to be predicted, is dependent. Right. So we have dependent variables and independent variables. So dependent variable depends upon the independent variable. So the dependent variable is the variable whose value has to be predicted or estimated based upon the value of or the given value of the independent variables. Correct. So one or more than one independent variables. And that is why, so whether correlation analysis or regression analysis, so we have simple correlation analysis and regression analysis and multiple correlation analysis and regression analysis. Simple means the study of only two variables, out of which one dependent variable, another one independent variable. Right. Multiple means one dependent variable, more than one independent variables. That is multiple correlation analysis or multiple regression analysis. Correct. So one variable depends upon one or more than one independent variables. Production of crop depends upon the rainfall up to a certain point, perhaps not related to the rainfall which we find now. This is a strange situation, and of course if weather conditions change in Arabian Sea, these things occur, but as far as crop is concerned, we cannot say that as the rainfall increases, production of crop go on increasing, like that we cannot say. Up to a certain point. Therefore, production of crop depends upon the amount of rainfall. Where production of crop is dependent variable and the amount of rainfall is independent variable. And if we consider only for our study, I am saying, so if we consider only rainfall, then it becomes a case of simple correlation and regression analysis. And of course, production of crop, we know that not only depends upon rainfall, but also in actual practice, but also upon many other independent variables. We cannot say that only if we have rainfall, then we can predict what's called the production of crop. It depends upon not only the rainfall, but also many factors, fertilizers, labor, good soil, and all those things. So multiplicity of factors exert influence upon the production of crop. Right. So, there may be certain cases where we may have to consider only one independent variable. All other variables, even if you find that there is influence of such other variables, their influence is considered to be not significant, insignificant, and that is why may not be considered. For example, in case of economics, so your expenditure and income. So income and expenditure, correct, as far as economics is concerned. So your expenditure depends upon income level. So income is the major thing. Perhaps in this particular case, we may consider only one independent variable. Other variables may be there, but their influence is not considered to be significant. And therefore, in the long run, so what do we say, technically speaking, their expected value, the expected value of other independent variables which are not considered to be significant is assumed to be or is equal to 0. It's nil. And therefore, income and major independent variable influencing your expenditure level, that is income. Correct. Income and expenditure. Therefore, your expenditure depends upon the income level. Correct. As the income level increases, correct, the expenditure increases, or as the income level changes, the expenditure level also changes. But anyway, in general we can say, if we have to study only two variables, of which one must be the dependent variable, another one is independent, simple. Otherwise, one dependent variable and more than one independent variables, then that becomes a case of multiple correlation and regression. And more than one independent variable, so here we are not studying this one as far as just from the point of view of the syllabus. So we have different techniques, MANOVA or etc. Right? Multiple analysis of variance or something like that. So analysis of variance, many statistical techniques are there, wherein or discriminant analysis. So all these techniques are there, wherein you may find that more than one dependent variable depending upon the independent variable which has to be studied. But here we are not concerned with, or we are not, it's beyond the scope of this class, at least from the point of view of our syllabus, right, to consider all these cases where we have to consider more than one dependent variable. So here we have only one dependent variable, that's all. Now coming to the correlation analysis and regression analysis. There is one regression analysis is used for what's called the prediction or forecasting of the future value based upon the value of one or more than one independent variable or variables. That is regression analysis. Now, using correlation analysis, we simply determine the strength of the relationship and also the direction of the relationship. The strength of or the extent of the relationship is given by what is called coefficient of correlation. So it is given by coefficient COEFFICIEN, coefficient of correlation or correlation coefficient. Okay. So I think some meaning aspect I already put it in your movie class. Right. So usually it is denoted by all these symbols, which simply we use all those things are there actually. So it is denoted by small letter R, especially when we have simple correlation, one dependent, one independent. Here multiple correlation we use capital letter R. So multiple correlation analysis. Right. So using correlation analysis, so we simply find out what is the degree of relationship given by R. And the coefficient of correlation always varies between plus or minus 1. Minus 1 and plus 1. 0 also there in between, inclusive, between plus or minus 1. So note that the sign plus or minus. So this indicates the nature of the so we have essential law of demand in economics and other things being held constant. As the price level changes, the quantity demanded changes. And you can find here, the other things being held constant, you can find here what's called not a direct relationship, inverse relationship. That's what. As the price level increases, quantity demanded, this is very important, not the demand. Demand and quantity demand. Very different in economics. Here we are concerned with only quantity demand. So as the price level increases, quantity demanded decreases. Correct? And vice versa. When other things being held constant, so this you should note. As the price level increases, quantity demanded decreases. Other things being held constant in the sense that, say other things, but maybe other things according to you. So if other things start influencing this relationship between quantity demanded and price, then this type of relationship, negative relationship, does not hold good. And can you say which other things? Any one of the other things? Which one other things? Say income level. Suppose if income level increases, then it is possible even if the price increases, quantity demanded may increase. Right? Population size increases, then even if price increases, the demand for quantity demand for certain items may increase. At least for essential items, say food items. Right? Just because price increases, we cannot find very difficult point a person, say price increase, therefore you may find it difficult to get the item, that is it. We cannot say that he will live without it for a long period of time. Once, twice, at least once in a day, he or she could that. That is it. So as the population, all these things must be held constant. Income level same, population size same, right? GDP same, other things being held constant. Then here we have what's called a negative correlation, that is minus. As one increases, another one decreases. Right. So that is what's called the negative relationship. Likewise, between price level and quantity demanded. Now price level and supply. What is the relationship? Price level and supply. As the other thing we get from. As the price level increases, supply by the sellers, quantity demanded by the customers, not the Therefore, as the price level increases, what happens to the price supply? Tell me loud. You are right. Increases. Right. Supply increases. Now you may ask how we can say that. So I will start a business and immediately I will raise the price. But I will see that my sales volume is not increased. Then how can you say that supply is increased? You may ask me a question. But here the assumption. So when you have to pick, when you cannot ask, if you want to start a business, then you cannot simply increase the price. Correct? You must study you have to scan the environmental scan. Correct? You have to study the environment. Usually when you increase the price, when demand is not simply just because in the class it is told that as the price level increases, supply also increases, therefore I will increase the price. You cannot say like that. Correct? So there are certain assumptions. Correct? Say you can increase the price only when there is increase in demand. So then we increase the supply level, so increase price level increases, supply increases. Correct? Like that, from the point of the seller. Because seller is interested in increasing the sales volume. He or she cannot say that price level increase, therefore let me increase the supply. that is the case, we will read further. This is not a legal business, right? Hoarding or something like that. Right? So we find all these what's called illegal activities or something like that. Right? Sometimes, especially whenever there is shortage of items, possible, artificial shortages. Right? So all these exceptional cases are not considered. Whatever we discuss, unless otherwise stated, so in normal situations, we will have a specific situation and it will be stated well in advance. So this is the situation, hoarding is there, therefore this does not hold. So that's why all other things we held constant. Right. So here we find what's called a direct relationship. Plus means as one increases, other also increases. Graphically speaking, so we have vertical axis and horizontal axis. Right. So usually say this is given to x and this is y. Say this is price and this is supply. Right. So price this much, supply this much. Price this much, supply this much. Price so right. So like this. As the price level increases, supply also increases. But as far as quantity demanded is concerned, you cannot say that. Direct relationship. Indirect relation. Low price, more quantity demanded. Right. So like that. Inverse relationship. Right. So as far as correlation analysis is concerned, know that it measures or it summarizes in single figure both degree and direction of the relationship between the variables. So degree between plus or minus 1. And you don't know that if we find a value 1 plus or minus 1, that is called a perfect correlation. Perfect correlation means, so degree 1, so we find that both the variables say change in such a way that variations or in such a way that the variations in the values of the dependent variable is observed or is constant or is remaining same or is stagnant. That is what we can say. For a unique change in the value of the independent variable. Mathematically speaking, the perfect, the linear correlation. So whatever correlation or regression analysis for that matter, so we have to keep in one thing in our mind, that is, we are interested in linear relationship. At least from the point of view of the syllabus. So we, unless otherwise stated, so we assume that the relationship between the variables is considered to be a linear correlation. Right. So when the relationship is considered to be linear, when mathematically speaking, if the relationship is of this type y equal to a plus bx, right. So this case of regression equation, usually we write y hat like that is symbol. So y hat means it is estimate. So this gives the estimated one. So later when we take up regression analysis, we take case 1. Ultimately we want to develop this type of equation. Case of regression analysis. Right. And y means what? So we have actual values, say denoted by y, actual values, say production of a particular item, y. 100 tons, 110 tons, like that some values are given, actual values. Say, in case of time series analysis, we say the important independent variable time. Time is the independent time series. We don't find any other independent. Over a period of time, let us say 2001, certain number of minutes, 2002, say 7, 2003, 11 values. Time series here. So this is x, and of course this has to be converted into, in case of time series analysis, what we do. So x means deviations of timing is
from one of the given years. It can be from 2001 or 2002. If it is 2002, then 2001 minus 2002. That's what we write, the expense. Then it is minus 1 here. And here 0. So like that it continues. And it is from deviations from 2001 means 2001 minus 2001. So here it is 0. And here 2001 minus 1 minus 2 like that. So that's how we get X values. Okay. Or in case quantity demanded and price, say price independent variable. Quantity demanded, dependent variable. Say denoted by what? Quantity demanded, price. Correct. Or time production of a particular item. So we have to develop a regression equation. And to get this particular equation, we have to solve linear, simultaneous, and normal equations. That's what we see. Actually. So one of the equations that is summation y equal to n plus 3 summation x. Take another equation. Summation x1 equal to a summation x plus b summation x square. So you have to solve it. Not data basically. Equation. So when you solve these two equations, some basic mathematics you must be knowing. In mathematics, operations, basic things, addition, multiplication, subtraction, all those things you must be knowing. Okay. Solving of equations simultaneously, you must be knowing that equations, how many equations are there or to be solved simultaneously. It depends upon what? It depends upon the given variables. Variable means the characteristic, which varies, and therefore whose value has to be determined. That is variable. So here variable means in this particular equation, say y production of crop is variable, x time is also variable, quantity demanded, price, these are all variables. These are all called variables. Why? Because they vary. Price varies from time to time, from region to region. Quantity demanded also varies. Correct. In general, variable. Correct. So, as far as this regression equation is concerned, so you have to automatically determine the value of a dependent variable given the value of independent variable or variables as the case. Correct. So we determine the values like this, y, x. Then we have to develop the equations. So based upon the solution of these equations. How many equations are there? It depends upon how many variables are. If let us say 2x equal to 10, 2x equal to 10. Correct. Therefore, to determine ultimately the value of variable has to be determined. Correct. Value has to be determined. To determine the value of a variable, how many equations you require? There is only one variable. So then you find x. How much x? 2x is 10. What is x? 5. How did you determine? Simple. Mathematical operation. Cross multiplication or something like that. So 10 divided by 2. How many equations are there? This is an equation. Equation means an expression with values with some terms with the variables on both the sides of the equal side. Both the sides. This can also be written as 2x minus 10 equal to 0. It is also an equation. 2x minus 10 equal to 0. Therefore, 2x equal to, these are basic things you must know it. 2x minus 10 equal to 0. Now, 2x equal to, take this to this side, it is 10. So there are usually, when you go for the solution of the equation, you keep, there are two parts, constants and the terms which are not constant. Constant. 2x equal to 10 or 2x minus 10 equal to 0. Only if it is 2x minus 10 equal to 0, then you can say that 2x equal to 10. Otherwise you cannot say. Right. Therefore what is constant here? What is constant? 2x. 2x is constant. Not 2x. It is 10. Okay. Constant means, why is what is constant? So it must remain same, constant. Then only we can use. Now when, why we cannot say that 2x is a constant? Because the value of 2x changes as the value of x changes. X equal to 1, 2x equal to 1, x equal to 2, 2x equal to 4, like that. But when I write 2x minus 10, note that you can find the various terms or variables. You can find the equation with various elements or terms with variable powers of x. This is called a linear equation. But this is a linear equation actually. So y so we differentiate because this is the actual value. Y means actual values. Using x values and y values we have to get estimated values. Therefore, the difference between this y and this y, this is the actual value. This is the estimated values or average values. That's all. Therefore, this is the empirical value. This is a theoretical value. Estimated values are theoretical values. Now you cannot expect that regression analysis is used for the purpose of estimation or forecasting. Therefore, using regression analysis, we must be able to forecast the things exactly without any. After statisticians are not tellers. So based upon some analysis, some reasonable estimation is made. But it does not mean that it is not subject to error. It is subject to error. Some variations will be there. But using these techniques, what is done? The amount of variation is reduced. Reduced to a level below which it is not possible to reduce. That is, however, it does not mean that we can estimate the future things very exactly. Particularly from the point of view of our field, the field of commerce and business or social science. It may be true in case of a physical science or a chemistry, etc. Where you find, so that is the case much more perfect correlation. Note that you can estimate the things without any error. 100% perfect estimation you can have only when you find a perfect correlation. Correct. In social science or in the field of commerce and business, we don't find this type of perfect correlation. But here we study, or we in most of the cases we assume that the relationship is linear relationship. Means perfect correlation or something. Correct. Why? Because for our simplicity. That's all. The techniques used for the analysis of non-linear relationship, which are found in actual practice, especially in the field of business and commerce, that are quite complicated techniques. It's beyond the scope of this class, and that is why, or even for some textbooks, it's beyond the scope of some kinds of textbooks. And that is why they say linear relationship, if any is of linear nature, not non-linear. Linear means of mathematical speaking of y equal to a plus bx. Means for a unit change in x, there is a constant change, certain amount of change dependent variable. Say y hat equal to 2 plus 4x. Amount of change in the value of dependent variable for 1 unit change in the value of x, that is 4 units of change. Okay. So therefore, graphically speaking, so y and x, so linear relation means only if equation is a linear equation like 2x minus 10, then it's a linear. Means graphically speaking you will get a straight line. Mathematically speaking, relationship is considered to be a linear, a perfect correlation. Correct. That is when the relationship is of y equal to a plus x. Mathematically. Graphically speaking, correct. So we'll have to relationship, we will have to get a straight line. This is graphical. Conceptually speaking, so we can say that relationship is considered linear. There is a constant change in the value of a dependent variable or a unit change in the independent variable. When x equal to 1, say y equal, estimated theoretical value equal to x equal to 1, y hat equal to 6, x equal to 2, 10, x equal to 3, 14. Note that 6, 10, 14, 18, 22, 26. So you find what? This will be fine. Means what? There is a constant change. Difference is what? Constant. What is the difference? 6. Correct? 6. When x equal to 1. So if y hat equal to 2x plus 4x, then when x equal to 1, y hat or estimated value 6. When x equal to 2, then 10. When x equal to 3, 14. So 6, 10, 14, 18, 22, like that it continues. Now you find a constant difference. 4, 4, 4, 4. That is this 4. Actually this 4. Correct. For a unit change in x, we write x equal to 1, 2, 3, 4. You will find what? Y hat equal to 6, then 10. So like that. Correct. Actually, mathematically speaking, this type of a straight line is called a arithmetic straight line. Because in mathematics we have two chapters, arithmetic progression and geometry progression. Arithmetic progression means it is a series where you find a constant difference. 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 3, 6, 9, 12. These are all the cases of arithmetic progression. Means a series. It is a sequence, in fact. When terms are connected with plus or minus sign, it becomes a series, mathematically speaking. Therefore, it is a sequence where you can find, if you know the common difference and the first term, you can write the entire series. Common difference 3, first term 8. First term 8. You can write the entire series. Common difference is 3. So usually common difference is, you can say, if you study arithmetic progression in mathematics, then for our convenience usually what we say, common difference is found by subtracting the immediate preceding value from capital value. Right. So 1, 2, 3, 4, 5, 6, common difference means 2 consecutive terms. 2 minus 1, that is 1. Right. For convenience. Or as a rule, for our department. 3 minus 2, like 4 minus 3. But conceptually speaking, whether it is 2 minus 1 or 1 minus 1, but you have to follow the same method. First case in the reverse order, then another order. First case 2 minus 1, then 2 minus 1. And in one case you get plus 1 and another case minus 1. This should not be there. You are subtracting to understand conceptually. You are subtracting. If you are subtracting succeeding value, immediately succeeding value, then follow the same for all the values. 1 minus 2, 2 minus 3, 3 minus 4, minus 2, minus 1, minus 2. If you are subtracting immediately preceding value, then you follow the same. 2 minus 1, 3 minus 2, 4 minus 3, 1, 1, 1. So this is a case of arithmetic progression. So this is an arithmetic regression equation. Here you can find, so now for B means constant. Graphically speaking, B indicates the slope of SLOP, slope of this particular regression equation, slope. What is the slope here? No slope, usually. For our common sense, we say, we need not, when we are entering into this class, we need not enter like this. Correct. Simply, there is no slope. Correct. Therefore, graphically speaking, do you find slope here? Do you find slope here? You find. Correct. Do you find slope here? No slope. Therefore, graphically speaking, If regression equation is parallel to horizontal axis x, no slope. Means this must be b must be, let us say constant, meaning constant. This is a constant, in terms of a value we are saying. If it is 4, here 4, therefore 6, 10, 14, 4 is constant. If it is 3, then you will find common difference 3, 3, 3, 3 like that. Therefore, constant word is used in terms of the value, whether it remains constant or not, that's all. But conceptually speaking, and this particular constant measures what? This measures slope. This constant therefore measures, assuming that there is a linear relation, that's very important, measures slope. Therefore, if there is no slope, what is constant? That's my question. Or at least I ask like this. So here you find slope, correct? Here you find slope. This is the case. No slope is there. But here, no slope. Therefore, what is the value of constant? Or what is B means, you have to tell what? What is the value of constant? Constant measures slope, correct? There is no slope. Therefore, what is the value of slope? It is? Yes, you are right. Because you give the best answer everywhere I say. It's good. Correct. And even if you give wrong answer, so at least you have to tell the answer, that is more important, whether it's right or wrong. So honestly you have to try, that is more important. For me, process is important, not the end result. The process is good, end result will also be good. Correct. Sometimes we are under the impression that only we have to give the correct answer, and if I give wrong answer, what if others think of my ability? Therefore keeping quiet. Don't think like that. If you have to develop, you have to answer whether it is right or wrong. Forget about, because if path is good, sorry, if destination good is good, path is also beautiful. Correct. If destination is wrong, path will not be beautiful. Correct. So you attempting answer is more important. And then, so if you give the right answer, you should always appreciate. That is correct. So, no slope means what? Value is what? Per slope. So, value means in terms of numbers you will have to say. Correct. Value, whether it's 1 or 2. When you say no slope, what is the value? 0. That's what you will have to say. So, corresponding to this axis, parallel to horizontal axis, correct, this relation goes. Here V must be 0. Therefore, this type of equation cannot be represented by this type of regression. Now note that this is plus 4 correlation, positive correlation. As one increases, another one also increases. Right? 6, 4, 6, 10, 14, 18, x1, 2, 3, not that x1, 2, 3, 4, 5, as one increases, other one also increases. Constant, same difference. Therefore, plus 4 means positive relations. Correct. Therefore, graphically speaking, this is the appropriate regression. Therefore, representing this one, so if you are asked to draw a graph, you must draw like this. And if you draw like this is wrong. And if you draw like this is also wrong. So you can draw like this when this is negative. Quantity demanded and plus. One increases, another one decreases. Say if this is minus 4, not plus 4. Then definitely this is minus 6, minus 10, correct. 4 difference. Sorry, minus 4 difference. Not 4, minus 4. Correct. Therefore, minus 6 plus minus 4, minus 10. Then minus 1, minus 8. Correct. Then you will find like this. If it is 0, no. So, we find perfect correlation. Maybe in the field also physical science or chemistry. Correct. For example, H2O, 2 units of H, 1 into oxygen gives 1 into water. Right. 4 units of H, 1 into oxygen, 2 units of water. You will find like that. But can you say in the field of business, if we incur 1,000 rupees for advertisement, case volume is 100 units, 2,000 rupees, case volume is 200 units. Can you say like that? No, you cannot say. In the field of business and commerce, we don't find this type of linear relationship. But at least from the point of view of syllabus, we assume that the relationship is linear for our simplicity. That's all. Understand the concept? Because techniques used to analyze this non-linear relationship is very complicated. The linear relationship is therefore, mathematically speaking, is of the form y equal to a plus bx, where y is a dependent variable and x is a independent. B is the slope, and what is a? A is y intercept. That is, usually we say, when x equal to 0, what is the value of y hat? When x equal to 0, so this side plus 1, so that minus 1, minus 2, so 1, 2, 3, 4. When x equal to 0, what is the value of y hat? X equal to 1, so that is 6. When x equal to 0, x equal to 0, what is it? When x equal to 0, what is it? 2 plus 4x. X equal to 0, y hat equal to how much? It is 2, right? It is 2. Means when x equal to 0, the value of y, that is a and b are constants. Note that b is a slope, a is called y-intercept. Y-intercept. That is value of y, dependent variable, in the vertical axis, when x equal to 0, that is, this is a and this is slope. So graphically speaking, so you have to understand like this. So now correlation simply measures the degree and the direction of the relationship between two variables. That's all. Right. So it does not say which one is the dependent variable, which one is independent. Therefore, in correlation analysis, variables are considered to be symmetrical, in the sense that it is immediate for us as far as correlation analysis. Which one is dependent variable, which one is independent. That is why correlation coefficient R between x and y is the same as between y and x. No change. But regression analysis, there is change in the way in which we treat the variables. It is considered to be asymmetrical as far as the variables are concerned. That is, it matters which one is the dependent variable, which one is the independent variable. Correct. If we write y hat or y equal to a plus bx, then this is a regression equation of y on x. That is what we will write. Y on x. Means y is dependent variable and x is independent variable. Therefore, y equal to a plus bx. Now, this is not the same as regression equation of x on y. Correct. X on y is 1. X or x hat equal to a plus b y. Two regression. But coefficient of correlation same between x and y and x same. That is the difference between correlation analysis and regression analysis. Correct. One of the important differences between correlation analysis and what's called a regression analysis. Correct. So in correlation, so actually now to establish correlation, so we must be knowing regression analysis. But we can perform correlation analysis without regression analysis, at least from the point of view of class. That is why you will take what's called correlation analysis first. Otherwise, technically speaking, the realized situation when we go for analysis of data, first you will perform regression analysis. On that basis, because regression analysis is used for the purpose of estimation. Now we will find out to what extent this estimate is correct. To find out this one, we must be knowing what is the level of correlation. Perfect correlation, H2O, perfect correlation, 100% correct estimation. Correct. Correlation, correct. But of course, here we can perform correlation analysis without regression. Another point, so we have might have considered some problems involving only one variable. Only one variable. X values are given. And you are asked to calculate average or standard deviation, etc. Think of option 10 period. 100 units 200. Calculate average or standard deviation. So these problems are called univariate problems. Univariate distribution. Okay. But in case of the correlation analysis, we don't have univariate problem, but we must have bivariate or multivariate problem. More than one variables are considered. And therefore, when we have more than one variable, and if we find that two variables move in sympathy, so that movement in one is tend to be accompanied by the corresponding movement in the other variable, then these two variables are considered to be correlated. Correct. That is the meaning. Correct. In case of the correlation analysis, correlation is measured through what is called correlation analysis. Correct. And correlation coefficient is a value which summarizes in one figure, in one number, both the degree and the direction of the relationship. Correct. Between 1 and 0 and 1 degree. Plus or minus direction. That is why plus or minus. Actually, degree varies between 0 and 1. Correct. Strength. Correct. Strength we have to consider only positive values. That is why I ask. Correct. 10 kilograms, 60 or 70. Nobody says the weight is minus 10 kilograms. Nobody says. Correct. But the nature, it must be negative. Correct. So correlation function R. So there are certain definitions you might have already noted in this class already. Just to say, because one of the concepts and how I defined correlation analysis. Correlation analysis deals with the association between two or more variables. When there are points like this, correct. When what's called variables, two variables moving in simple, so that movement in one variable to be accompanied by the corresponding movement in other inside the bracket, yes. More than one. Other variables or variable, then they are said to be correlated. L or one or like that, one of the others. Just see uploaded materials that you are will be uploaded. Correct. So like that. Then Croxton and Cowden defined like this. When the relationship is of quantitative nature, correct. The appropriate statistical tool used for the purpose of discovery and measuring the relationship and expressing it in a brief formula is called the correlation. Correct. So another author, Ya Lun Chow, defined like this. Correlation analysis attempts to determine the degree of relationship between variables. Correlation is analysis of covariation. Covariation between two or more variables. These are all the definitions. Therefore, correlation analysis is a scientific device, which is used for the purpose of analyzing the covariation between two or more variables. Actually, the problem of correlation analysis must be broken down into 3 steps. First thing, we will have to determine whether actually the relationship exists or not. First thing. And then what you will have to do, if the relationship does exist, then you will have to determine whether it is significant relationship or not. This is a case of test of significance. You might have studied test of hypothesis. And next, if it is a significant, then you will have to establish what is called cause and effect relationship. And just because you find a high degree of correlation, or even in regression analysis, you find a more value for constant, just because a high degree of correlation, you cannot say 0.95 correlation coefficient based upon this is simply a mathematical result for your kind information. You cannot directly establish that there is a cause and effect relationship between the variables. Establishment of cause and effect relationship is to be considered beyond this mathematical relations by considering the real life situations. Correct. We may have to make an appeal to real life situations, or we have to make an appeal to what is called the theory. Income and expenditure, we make an appeal to the economic theory. It's already established that income causes expenditure. Rainfall and crop
rainfall and crop, for that don't referring to theory, common sense. Correct. If rainfall is there, crop will be. For that purpose, it is not because of you got 0.9, therefore cause and no, not like that. Correct. So cause and effect relationship, analyzing this. So like this, there are three aspects. Correct.